Hello, today we're going to add this conductor nut liquid metal paste to this rather old MacBook Air. We just did a Cinebench test on it and it scored 104 on Cinebench, so it's pretty low. It topped out at 97 degrees Celsius, which is just perfectly fine actually. But we're going to see if adding some liquid paste will change its performance characteristics. I did that on my 2012 MacBook Pro Retina, and it didn't actually change much, but it did make it a little bit faster. It gave it about a 13% increase in the Cinebench score. And what it really does is lowers your idle temperatures. Because these computers have pretty limited heat sinks, but so the maximum amount of heat that you can remove from these computers is somewhat limited by the design of the heatsink. But at the same time, by upgrading the heat paste, you can reduce the temperature at which your computer operates normally during like normal operations, during idle, which reduces the heat of the computer and makes it more comfortable to work on. So this is what we're going to do today. To do this, you need the liquid metal conductor nut paste, and because this liquid metal paste is conductive, you also need something called silicone conformal coating. This is something we're going to paint around the CPU to keep the paste from shorting out all the resistors and such that are around the CPU. So now I'm going to open up this computer quickly, and we will see what's inside of it. You'll need a pentalobe screwdriver. It's the P1.2 to take apart most Mac products. Oh, this is dirty. As you can see, most of this MacBook is battery. It has some soldered on memory right here. And this is your hard disk. And these are your two processors, a GPU and a CPU. Not actually sure which one is which. So we're going to take it apart and we'll see. But first things first, we want to disconnect this power connector right here. This will disconnect the battery from the motherboard. That's important so we don't short anything out or anything like that. This one is actually fairly simple. You just need to pull back this little rubber piece right here and the little seal piece, and then you just take the whole thing out. So let's see how difficult that is. I actually have never taken this computer apart before, so this is a first for me as well. So Apple likes to use these T5 screws for a lot of their screws on the motherboard. So you'll need a T5. And you want to remove the screws around the heatsink, around the CPU / GPU. And I think in this particular model, they're all the same, but it's always a good idea to keep them separate, because not every, for instance, on my 2012 MacBook Pro, the screws are different, and actually even the screws on the same chip, there's two different screws that connect here and two different heights of screws that connect here. So sometimes that happens. So ideally you want to keep track of where your screws are coming from. And we're back. Actually, our camera ran out of storage, so while dumping the card to the computer, I decided to take apart this computer a little bit more, just to see how it's built and such. And I took out the battery. This is the battery that Apple used to use. And The cool thing about this battery is it's held in with 1, 2, 3, 4, 5. 5 screws. 5 screws hold this battery. So to replace this battery, all you have to do is undo 5 screws. And you take out the battery like this. And you plug the new battery in. And you're good to go. And you also have access to this touchpad. So if something goes wrong with the touchpad, you can undo some of the screws, undo this ribbon cable right here, replace the touchpad, and you're good to go. However, on the 2012 MacBook Pros, on the Retina lines, this battery is glued in. And it's glued in so much that it is almost practically impossible to take it out. Now, you can heat up the computer and you can spatula it out, but it's very difficult to reuse the battery afterwards if you're not replacing the battery, but for instance, replacing the touchpad. And it's idiotic. If you actually pay Apple to do it, and admittedly Apple charges $240 to replace the battery, which is not as bad as some people think, but when Apple does it, they replace the entirety of the bottom of the computer. So that means that they have to take out the motherboard, or the logic board as they call it, and they have to take out everything out of the computer, and then they undo the screen. They give you your old screen, but they take out this portion, this chassis, and then give you a whole new chassis. It's idiotic, and Apple just recently announced how they're now 100% green and 100% renewable energy. It's idiotic and very, very environmentally conscious to throw away an entire chassis or to recycle the entire chassis simply because your engineers decided that gluing in a battery is better and cheaper and, name a reason, than using 5 screws to attach it to the main board. Now, if you can zoom in right here, the other idiotic thing that Apple already started doing, even on this computer, is attaching the keyboard with these rivets right here. So if something goes wrong with your keyboard, you can't just remove everything, undo the keyboard, remove the keyboard, put a new one in. No. You have to rip out the keyboard and then snip away each one of these individual rivets, of which there's dozens. And then you have to get a special kit that allows you to tap into the holes where those rivets go and reattach a new keyboard. It's, of course, again, Apple does this for you. You can pay Apple to do this, and they'll be happy to take your money. And most people will be happy with the fact that you can fix it with Apple. But the problem is that, again, it's extraordinarily environmentally unfriendly because, again, they just replace the bottom chassis. The bottom chassis gets recycled somewhere in China and remelted into new aluminum. God knows what they do with it. But it is far less ecologically friendly than actually designing this computer to be repairable from day one. Okay, so that's an aside for a different day. That's end of my rant, and now I can get off of my soapbox and continue the heat paste upgrade. Now, this is not a video showing you exactly how to do it on this particular model of a laptop, because what are the chances that you have this exact MacBook? But for those that do follow this, and this is a 2011 MacBook Air, I was going to show you that once you undo these 8 screws around the perimeter of this heat sinks, there is another little screw that hides right here and attaches the end of this heatsink by the fan, or the end of this heat pipe, rather, I should say. There's the little screw right here, so I took it out. And when you take out that little screw, you can kind of use your nail to move around this piece, and you see, okay, it's done. Then, don't lift it up from here, because you're going to break it. Always wiggle these heat sinks right here until they become unstuck, and then slowly slide it out. And when you slide it out, make sure to blow out, I already done this, all the dust and stuff that gets trapped in here. And you might as well blow out the fan just to clean it out. Okay, so now what we need to do is we need to clean off all the old gunk, the old paste from the old heatsink and from the CPUs itself right here. So let's get going on cleaning off the CPUs first. To do so, we use 91% isopropyl alcohol. And it doesn't really matter, but just use alcohol, like clean isopropyl alcohol. And you'll need Q-tips and a little tub for the alcohol. And you just weten your Q-tip and you just basically do one of these circular actions to clean off all of the old heatsink paste. Actually, before I started doing this, I had the same issue with my with my MacBook. We're gonna go ahead and rip away these stickers. Now, Apple puts these stickers on their CPUs and their GPUs because the boards underneath them are slightly different color, and Apple being Apple and being very obsessive about things like they are, they want their entire board to look black. Unfortunately, you don't get to reuse this nice little black sticker for reasons that I'll explain in a second. But you need to remove them. And to remove them, you can just use forceps like I'm doing like this. Lift it up from the edge. And then once they lift up a little, you just rip them off. Make sure you don't rip off any chips with them, any resistors and capacitors, but do so carefully and you'll be fine. So once you clean off, once you remove those pads right there, you can just go back to cleaning the chip and removing all of the old stuff that's caked on and separated from the die itself, or that was squeezed out away from the die. When you're removing this stuff, just be gentle. You don't want to knock off any of these resistors that are located around the die itself. And this is, by the way, it looks like this is the GPU, and this must be then the CPU, because this one says NVIDIA on the top. And just apply alcohol around and let it kind of sit there and penetrate the grease, the thermal grease, and then just wipe it off as best as you can. You want to clean off as much as you possibly can on the chip itself, and use as many Q-tips as you need. Q-tips are cheap. You can buy 100 of them for $1. So sometimes it's helpful to break off the Q-tip like this. So you have a paper, it's basically a paper stick. And then you can very carefully, and again, be careful because there's a lot of small resistors here, but you can get in here and you can clean off some of the stuff that is left behind. So we're going to do this right here. And we're going to clean off right here. And right there. Okay. So this grease is not conductive. The grease that Apple uses and the grease that is traditionally used, by all manufacturers on these laptops is a non-conductive grease. So this is why they don't care about the fact that it's touching the little resistors around there, because there's no harm in it. But the grease that we are going to be using, the liquid metal grease, that one is conductive, and this is why we have to use conformal coating to protect all of these little chips around the perimeter of the die. So let's put a little bit more. A little bit more alcohol in there. And let's clean this off. Let's pick this piece up. I'll use tweezers. Okay. And let's finish cleaning this one. So it takes a few minutes to get everything out of here, but it's well worth it because it's going to make a much cleaner job when you conformal coating it. And let me get alcohol dries up really quickly, so alcohol is not gonna hurt your electronics, but do make sure to detach the battery. In fact, I can just move the battery here, just so it's in the shot. Yeah, we definitely detach the battery before you begin this process. Okay, so now it's pretty clean. I'm gonna use my broken off Q-tip trick to just get the last few bits of old grease from between these little resistors right here. Oh, capacitors. I think they're capacitors. They're power capacitors, just to smooth out the power delivery to the chip. Okay. I think that's pretty clean. It's clean enough, I suppose. Let's see. Sometimes what also helps is having some toothpicks. And you can go in here with the toothpicks and just get some last bits out. Again, just be careful because you don't want to knock off any of these capacitors. But they're soldered on, so they're pretty well connected. You're not gonna knock them off unless you go in there and just start destroying things. Okay, so let's get another Q-tip. Now we're gonna polish up the top of the actual heatsink. The top of the heatsink, or rather, I'm sorry, not the top of the die, needs to be nice and clean. So wipe it down with wet Q-tip and then make it nice and squeaky clean with a dry Q-tip. And repeat the same process for the CPU die. You want to make it nice and squeaky clean. And then make sure to completely dry it with the dry Q-tip. Okay. So now we are ready to apply conformal coating. This is a silicon modified conformal coating, and there's going to be a link to this and to everything I used in the description in the video, so check that out. It's from Amazon. But this conformal coating is good because it's stable up to 200 degrees Celsius. Now, if this ever heats up to 200 degrees Celsius, your CPU is going to be gone. So this definitely, usually CPUs go to about 100 degrees Celsius. So this has twice the margin of safety. And what we're going to do with this is, let's look closely over here. What we're going to do here is we're going to cover all of these little capacitors right here, and right here, and then these guys right here. We're going to cover them with this conformal coating. But what's important is we don't want to get any of it on the die itself. If we get any of it on the die itself, we have to clean it off right away because otherwise it's going to be a huge screw up. Because this stuff is not heat conductive. It's actually heat, it's an insulator. So to apply this stuff, what you want to do is use the brush that they give you if it is kind of shitty, but do the best that you can. And apply a thin, oh, I see a little bit of grease right here. I got left behind. Let's get that off. So the brush that they give you is kind of crappy, but try your best. And some more grease that just keeps getting in the way. Okay, try to get just the tops of the resistors, and as soon as you touch it, it'll basically just flow. And it will flow and spread throughout the entire board. So just try to cover up most of the board with it. You don't have to cover up every square inch of the board with it. But cover up anything that's electrically conductive, like this little side right here. And you can go on both chips, so you can get it. But get a relatively thin layer. The one mistake I did yesterday when I was doing this to my MacBook Pro is I applied a pretty thick layer of the stuff because I did 2 applications, one after another, and it took forever to dry. The manufacturer on their website says that this stuff is supposed to dry fully in about 20 minutes at 68 degrees Celsius, or Fahrenheit rather. So basically room temperature. So at room temperature, it's supposed to dry in about 20 minutes. And use this stuff sparingly because it's quite fumy. So if you have a fume extraction, that's nice. If not, open the window or a door. That would help, and try not to breathe too much while you're doing it. If you spill any of this on your board, on the logic board, and you don't really have to clean this up, so you can leave it alone. It's not conductive, it doesn't hurt your computer. In fact, it kind of protects your computer from spills and stuff. This is basically what they use on military electronics and electronics that are supposed to be able to withstand liquid damage and such. Or this is basically, that's a bad idea. This is basically what they do to make your stuff water resistant. They cover it in with this conformal coating, and it dries like lacquer. So it's basically the same as lacquering the top of your PCB. And it kind of smells like nail polish, if you are into doing your nails. Which I am not, but nonetheless. This is also really great for covering your flight controllers if you're into drone racing or something like that, because then if you ever land your drone in the water, or if you land it in the middle of a wet field, when the grass is wet and such, you don't have to worry as much about shorting out your electronics and about destroying your drone, because, or the flight controller, because this stuff will repel water and will not let the water short out your electronics. It's basically like a coating that protects your electronics. So as soon as you get a thin layer of this conformal coating on the board or around the dies of the chip, covering all the little capacitors, as soon as you do that, you can set the laptop aside. So I'm going to set it right here for a second, and then we can clean all the grease from these heat sinks right here. So that's, same thing, only a lot easier. You just get yourself a Q-tip, put lots of alcohol on there, and let the alcohol dissolve the grease a little bit. And then when it doesn't actually dissolve it, but it just makes it a little softer. It makes it wet, basically. Give me 1 second. It's fine. I'll just get a new paper towel later on. And I'm doing it on a paper towel. You want to do it on some kind of surface so you don't scratch your laptop, in case that wasn't obvious. So we'll clean off these heat sinks like this, and since I'm going to get a new paper towel anyway, I'm going to wipe this off right here. There, they're nice and shiny. So now we can polish them up a little bit. The liquid metal kryptonite stuff is only compatible, and they write it on the package and everywhere, it's only compatible with copper heatsinks. So if you see copper, this is orangey, so it's copper, that's fine. If you have an aluminum heatsink, so if your heatsink is silver for whatever reason, do not use this stuff, because what it does is it eats away into the aluminum, and then you're not really going to have any kind of conductivity, and your chip is going to overheat and shut off or burn up. Bad things are going to happen. So this stuff is only compatible with copper heatsinks. It's probably compatible with other types of heatsinks, but the only heatsinks that they really make is copper or aluminum. So that's pretty clean. You just really want to make sure it's, once it's nice and dry, you want to really dry it up like this. Really get in there to basically polish it up, and that's probably good enough. Be very careful not to bend this when you take it out. That's another thing I forgot to say, because this tube, this little piece of metal right here, it looks solid, but it's actually a pipe. That's why they call them heat pipes. It's actually a hollow pipe that has gas inside of there, and a wick that carries the heat out to this little area right here that actually cools it down. So if you bend it in half, what you do is you can straighten it out, but it'll never work as well anymore, because it will actually kink where you bend it. So I've done that before, so don't do that. And clean things off. And now we're going to wait for about 20 minutes or so while this dries. So this process takes about an hour to do in terms of labor, but it's going to take you about an hour and a half, 2 hours to finish, because you have to apply the stuff and then go watch a movie or do something while it's drying. So we'll see you in about 20 minutes. Okay, so we're back, and we're going to now apply the conductanate thermal grease. We allowed about 20 minutes for the conformal coating to dry, and after it finished drying, I came back and I applied another layer onto just the components around the die itself, just onto the resistors and capacitors, just to give them an extra layer of protection. So now we can take a look at it, and the way you see whether or not this is dry is you can use a toothpick like this, and you can poke at the conformal coating, and you will see that it'll be mostly dry. Like the toothpick is not going to stick to it. It may leave little indents, which means that it's dry, but it's not fully cured, but this is okay. And this stuff doesn't get really hard cured. It still remains a little soft even after weeks, which is fine for our purposes. So to apply the conductanate, and it's called conductanate because it is conductive, so this is why we're going through this trouble. So to apply this paste, in the bag you will get the syringe with the paste, and you will get one of these little application needles. Now I've seen a lot of people on YouTube not use these needles, and I think that's a mistake. You should use it, and it's easy if you do it properly. So you want to open up the cap. I'm going to make sure that there is stuff inside there, the thermal paste inside there, and then you screw on the little needle, right? Set this aside. The other thing that comes with the package is this special Q-tip. It's just basically a high quality Q-tip that has very dense fibers. I already used this one on my previous installation, but I saved it for this one as well. What you can use some of this remaining material remaining thermal grease that got left on the and this Q-tip from the previous installation to basically paint out the area on the heatsink right here. Now I'm just doing this really quickly. If you haven't installed it yet, then obviously you're not going to have a used Q-tip, so you can do it after you finish applying it here. Then you paint on a little bit of this material onto the heatsink right here. But let's apply it to the heatsink. So what you do is you take your syringe. You want to be very, very careful. Before you do that, actually, let's clean off the die, just so it's clean. You want to be very careful. You want to put your thumb in here, in between the syringe and the plunger, so you can kind of control how much you squeeze out. And you want to squeeze out just very, very slowly. Only about a little bit. There. Sometimes it doesn't want to let go. So, by comparison to the tip of the syringe, or the tip of this needle, here's how little of the material you're actually applying. Very, very little. And you just want to leave that little ball over there. I would say it's about 2 millimeters in diameter, and that might be actually too much. Then you take this Q-tip, and then you just want to slowly work it around the entire perimeter, or around the entire surface of the die. And as you're working it, you want to go all the way to the edge without slipping off the edge too much. And you basically, it's going to feel like you're basically painting it on. And that's basically what you're doing. You're not really applying a layer of thermal grease as much as you're basically painting on thermal grease onto the top of the die. It's going to be very different from the normal thermal grease applications. And you want to make sure that the entire die is covered with the thermal grease, but it doesn't pool in any particular area too much, especially towards the edges. Because again, we don't want any of the stuff to leak out onto the board, because again, it is called conductanate, and it does conduct electricity. So we want to not put any of it here. So we take a syringe again, and now we're going to cover this NVIDIA processor. So you put your thumb in between the plunger and the syringe again, and you very slowly squeeze out. Now the reason you have a thumb there is so that if you squeeze out too much, you can stop yourself with the thumb. And if you do squeeze out too much, like in this case right here, you can very carefully pull it back in. Less. Yeah, sometimes it doesn't want to let go, but you can just squeeze it around and then do the same thing. Start painting the top of the die. And cover the entirety of the die again without letting it pull too much in any particular area. And spread it around nicely so it's doesn't bunch up in any one area. And then you want to pick up excess. So if you see like a puddle of this material, if you see a puddle of the liquid metal, you want to take a clean part of your Q-tip, maybe the side of it, and you want to basically pick it up. And you can just spread it around some more. There. So now you can look up close. Basically, it's painted on, but there's no puddles, there's no layer per se of the material of the conductanate thermal grease on there. There's this little puddle that's bothering me a little, so I'm trying to get rid of it. That should be good enough. Because basically the way this stuff works is it just makes a really tight connection with the thermal sink. So what it's doing there with the heatsink, it's just filling all the little gaps and little microscopic scratches that you have on the heatsink and on the die. Not so much on the die as much as on the heatsink. You can't see them with your naked eye, but if you look at it under the microscope, the entire surface of the heatsink is pitted with little scratches and such. So what we're doing here is we're basically filling up those scratches, increasing the surface area that's contacting the chip. So now you want to take this heatsink, I'm actually holding it the other way around. You want to hold it the way it's going to go here, and you want to see how big those chips are, and just use like your eyeball or your eye and your best judgment, and just very gently paint, literally just paint the material onto the heatsink as well. And you want to pick up any excess material with the clean side of the Q-tip. And the same thing on this side. This one is a little wider. So we're going to paint it in a little rectangle like this. And then just pick up any excess, because you don't want any excess material on the heatsink itself, because you already have some excess material on the die. So you want to limit the stuff from squirting out and going all over the place. So it should look literally like you just painted on with a brush, just with silver paint. Come to think about it, this stuff really should come in a applicator. And this looks good. So now what we're going to do is take our heatsink. So now we're ready to apply it. Turn it upside down, and this is the important part. I'm going to slide it in so it aligns on the far side with the heat pipe. So now it's ready to go in. Actually, I'm going to go ahead and put in the screw lightly, in this case, on the far side of the heatsink, on the heat pipe, just to kind of fix it in place, because there is a rubber band that wants to fight this thing on this particular model of the computer. So I'm going to very lightly put in that screw. Then I'm going to align all of the screws on the die, and then when they're nicely aligned, I'm going to press in like this, and that's it. Don't let go. Don't let it move. Once you press in and aligned it, just put in a few screws so you can keep it there. And what I'm doing right here, you can see I put a neodymium magnet on the edge of on the side of my screwdriver, so that way I can pick up screws like this and they stay there as I'm screwing them into the heatsink. Let's get a few screws in here, and then we will tighten them. Don't tighten them all the way down, just get them in there finger tight, just so it doesn't move, doesn't shift around. Oh, picked up too many. Let's get this one in there. And let's get the last one. Oh, we have two more. So this one goes right here. And I could probably just let go at this point. This one, last one goes here. Okay, so once you get all the screws finger tight, for these things, and every computer is going to be a little different, but you want to go crisscross. So you want to start with the far one, so this one, and you go tighten this down. Then you go across, and you tighten the one across down. Then you go across, and tighten this down, and then you go across in a crisscross pattern, and tighten this down. Then when you're done with that one, you go here, then across, then across, then across. Once you're done tightening all the screws, you can tighten the heat pipe screw. In this computer, there's only one on this side right here. Then when you're done, go ahead and come back and just do another torque cycle where you just tighten them just a little bit tighter. Again, it's finger tight. Don't rip out your screws from your motherboard, but they have to be pretty tight, tight enough to hold the heatsink down into the CPU, so that way, you know, you're actually transferring the heat into here, and the heat is going to go up from the die into this heat pipe over here, and then here it's going to get blown away with this little fan right here. So then you just tilt in. Give me a second. You just have to realign this little rubber piece. This rubber piece just keeps the hot air from coming back in and make sure that the hot air goes out of the computer. Okay, so now you're pretty much done with this. We're going to put the battery back in. Again, I took out this battery just to show you how idiotic it is that Apple nowadays glues in their batteries. You don't need to do this if you're doing it on this computer. You don't need to take out these screws. But it doesn't hurt to clean your keyboard while you're doing this. And you have access to at least half of your keyboard from there. So you can take out all the gunk and stuff from the bottom of your keyboard. And we just screw these little screws in. You see how easy it is to change the battery on this computer, by the way? I mean, on the MacBook Pro, if you want to change the battery, you'll be here with a spatula, a heat gun, for about 2 hours, heating it, prying it, hoping against hope that you don't destroy your casing in the meantime, or don't set your computer on fire because you pierced the battery and now it's exploding in your face. It's not as difficult as I'm making it sound to be. It's definitely doable, but it's just a huge hassle. And even Apple themselves don't do it. They don't replace the batteries inside the MacBook. They just recycle the whole thing. They just give it away to some Chinese company that will deal with it. Okay, so we're gonna plug in this battery, and we're done. So on this computer, it takes less than 10 minutes to replace the battery. So you can save this little Q-tip because it's pretty good for this application. You can save it inside a little Ziploc bag. You're not going to use all of the conductor knot paste in one go for sure. So what you want to do is take your syringe and actually pull it back a little, because you will suck the paste in essentially. And then you want to get that cap. So it comes with a cap like this, and it comes with this tip that allows you to pick up some conductor knot liquid metal that you may have spilled. Don't use this to apply it. Do not use this to apply this. A lot of people on YouTube will show you how to use this. Don't. It's idiotic. I don't know why people do that. So once you suck in a little bit of the conductor knot, you want to carefully unscrew the tip. And you will see that the liquid metal is kind of inside there. And use your fingers to slowly push until the liquid metal is, again, be very gentle here. Until the liquid metal is at the edge of the, someone just called me, at the edge of the hole, at the edge of the opening, and you can get it a little closer, right there. And then when it's at the edge of the opening, you just use this tip and you screw it in there. And now it's ready for shipping. It's not gonna squirt all over the inside of the envelope. You're good to go. So you can put this back in there, put all the other stuff that it came with. And I mean, I already done 2 CPU GPUs with this, and there's probably enough here to do, like, I would guess at least 4 more, 5 more. 5 more sets. So I'm going to do, in the laptop, I'm going to do Dell XPS as well with this stuff. So maybe I'll shoot that video as well. Okay, so now we'll put the lid back on. And I'm not going to screw the lid on. That's boring. You guys can figure out how to do that yourself. But what I am going to do, yeah, look at all the stuff that came out when I was cleaning the computer. So now what I'm going to do is going to turn on the computer, cross my fingers, and wait for it to start. Boom. Okay, so the good news is there is no fire yet. I'm going to go ahead and do a Cinebench run on this laptop to see how it runs, and I'm going to come back and talk about the results. Cinebench runs forever on this computer, so I'm not going to do that on camera. Bye-bye. Hi there, and we're back. We just run Cinebench on this laptop, which takes forever. This laptop scored before 104 on Cinebench, and after this application of the thermal grease, it scored 112. So maybe 8% improvement, something like that. Very, very small improvement. But, and I think this is because this computer is primarily CPU bottlenecked in terms of Cinebench. It's just, very low power mobile CPU. But in terms of temperature, the temperature dropped from 97 maximum in the test before to 85 maximum right now. I'm going to go ahead and take a screenshot of this, and show it on the screen. And basically what you guys can see is the tip at the very top of the chart is, right on this chart is 85, and on the other chart that we've done before the application of the conductant grease is 97. So again, 97 to 85, that's 12 degrees reduction in temperature. That's more than 12%. That's 13% reduction in temperature. And what that really means is, you're not going to be doing video editing on this computer, and you're not going to be doing gaming on this computer. But what it does mean is on a hot day or in a hot room, when you're using it for web browsing or using it for Facebooking and things like that, it's not going to heat up as much. It's not going to kick in those fans as much. And it's just going to run a little bit more stable, a little bit more cooler, and it's just going to be a little bit more pleasant to use in a hot environment. And in a normal room temperature environment is just not going to kick in that fan quite as often when you're watching YouTube videos or going to Netflix and things like that. So is it worth the paying $30? Because that's how much it costs to buy the conductive, or rather the conformal coating and the conductanot paste. Is it worth $30 for this laptop? No. Is it worth doing it for this laptop? Yes, if you're already buying this for your other computers, if you're already buying this for your other MacBook, or for your gaming rig or anything like that. And if it can do this on a laptop like this, I think it's going to perform outstandingly on a gaming rig or on a high-powered computer with a good heatsink, where the heatsink can actually dump the heat that you will be dumping into the heatsink using the thermal grease. So if you're already buying this for some other application, it's well worth it to upgrade, your portable computer as well, because why not? It's going to be way more pleasant to use. It's not going to heat up as much. But if this is the only reason you're buying it for is to just upgrade your MacBook Air, use your money some other way. It's just not worth it. Other than that, hope you enjoyed this and hope this helps you apply this in the future. I'm probably going to do another video on how to do this on Dell XPS 15. It's the 9550 model. I'll probably do a quick video just to show how to do it in that particular model. But other than that, have a great day, and I'll see you later.